Hello everyone. Today's presentation is on spam detection, which is done under the supervision of Ms. Deepthi Sehrawat, Assistant Supervisor, Professor, Computer Science and Engineering at MIT University, Haryana. As the meaning of my name suggests, I'll be leading you throughout the presentation and I'll let you know what it is all about. For all the days prepare and meet them ever alike. When you're the anvil beer, when you're the hammer strikes. So let's just start on with what I have done here. Spam is any kind of unwanted, unsolicited digital communication, often an email, that gets sent out in bulk. Spam is a huge waste of time and resources. It is really irritating. Software providers invest resources creating email applications that try to filter most of the spam out. Consumers waste a lot of their time shifting through whatever makes it past them and spam filters. According to Oracle Dine, the total cost of spam in terms of productivity, energy, and technology adds up to 130 billion US dollars. It is an annoying and endless cycle. The concepts that are widely misunderstood coagulated as one are spam, fraud, and duplicate. Spam, as referred before, is an irrelevant messages or group of messages sent over the internet, typically to a large number of users for the purpose of advertising, phishing, spreading malware, etc. Fraud, whereas, is termed as an intentional deception to secure unfair or unlawful gain or to deprive a victim of legal right. Duplicate stands for basic definition is as to make an exact copy of something, it is the copy of the original. The problem statement that the project is all about is to detect deceptive and truthful data from the dataset so selected. That to detect is to be able to identify the parts in classification. Machine learning models and algorithms can be implemented in order to classify accordingly. To make a user-friendly and viewing easier, specific data has to be and is to be accessed and utilized. The methodology of the model so created is as the data set is inserted, it is removed, the outliers are removed, the useless columns are removed, the non-available values or the empty values are filled using the fill NA. Created relatable values are created, and then the trace and train model is created. Finalizing the model, then we are able to predict the result needed. The previous slide was somehow not very precise and very clear on exactly what it is that we have to do in order to get our machine learning model all set for the detection of the deceptive and truthful data in the set so procured. This is why we need to study and understand the technology and dataset used. The dataset precisely consists of 5 columns and several rows. The columns consist the data deceptive and truthful combined as one: hotel, polarity, source, and text. This particular dataset showcases the text which are deceptive and truthful for various hotels given by various categories of people. The technology that has been used in order to detect the spam, that is the deceptive or truthful inputs by the customers, is termed as machine learning. As said by Nick Bostrom and Bill Gates, machine learning and machine intelligence is the last invention that humanity will ever need to make. A breakthrough in machine learning would be worth 10 Microsofts. In order to use machine learning, we use Jupyter Notebook in Python. Jupyter is a non-profitable organization created to develop open source software, open standards and servicing for interactive computing across dozens of programming languages. Spun off from Python in 2014 by Fernando Perez, Project Jupyter supports execution environments in several dozen languages. And there are some codes that might help you understand what machine learning is all about. Introduction to machine learning. It is an ordinary system which is used with the AI models and algorithms with the help of humans, termed as machine learning, which is needed to learn, predict, and improve the overall standards of human life. The environment and possibilities so provided by AI proposed Jupyter Python is used in applications of algorithms such as label encoder, decision tree, SVM, that is support vector machine, logistic regression, which are also used in our ML model. The label encoder that has been used in my model is an approach to encoding categorical values. It refers to simply converting each value in a column to a number. Label encoding in Python can be achieved by sklearn library. A label is a Twitter widget class which is used to display text or an image. And this is the display of label encoding so uh, executed in my program. Then the a decision tree or a decision support tool that uses a tree-like model. Sorry. model of decisions and their possible consequences. It is one of the way to display an algorithm that only contains conditional control statements, commonly used in decision analysis, also a very important tool in machine learning. And so the application and implementation part has been shown in the machine model that I have made my project on. The support vector machine, or known as SVM, are supervised learning models with associated learning algorithms that analyze data used for classification and regression analysis. And so the implementation. Logistic regression is a statistical model that in its basic form uses a logistic function to model a binary dependent variable. In a binary logistic regression model, the dependent variable has two levels. Outputs with more than one values are modeled by multinomial logistic regression, and if the multiple categories are ordered by ordinary logistic regression, and so the implementation using the sklearn linear model library. The dataset that has been taken in the course of selection of the problem statement consists of 5 columns, so mentioned earlier, and to be precise, 320 rows. The dataset so selected has been perfectly utilized by the models in the project in order to depict the spam, non-spam, or so to say truthful or deceptive data entries. It has no missing or NaN values. That is the dataset so taken is a clean dataset. The relevant attributes are the entries in hotel, polarity, and source columns. This is a screenshot of the dataset that I have taken, which shows first column shows the deceptive and truthful entries, the hotel names, the polarity as positive or negative, the source, which consists of the various categories of people, and the text that they have so entered for the hotel. Data preprocessing. The import of libraries such as pandas and matplotlib have made it easier and convenient for the model to function. The value count or the value count function that has been used for the column deceptive are equal. That is, the deceptive and truthful entries are equal, as shown 1600 each. Using pi representation, it is made clear that the dataset is equal, that is deceptive 50% and truthful 50% each, light blue and light green respectively. Unique values describe the unique entries of certain columns, that is hotel, source, and polarity. The basic information is provided by using df.info function, which describes the entries that are all in columns as object and so highlighted. The input and output. Now, while working on machine learning models, we have a certain amount of dataset that has been used as input, and a set of dataset that is used as target or output. As the next step is breaking the dataset into input, that is X, and output, that is Y, we need to drop a few irrelevant columns here, that is deceptive and text for the input. Similarly, for the output, consists of only deceptive column, as we need to know the aim of the model is to know whether the entries are deceitful or truthful, and so highlighted as 2, 3, and 4, whereas 1 denotes it is truthful and 0 denotes it is deceptive. Splitting X and Y, that is input and output in training and testing dataset. The splitting of data into training and testing sets requires library, which has been highlighted as point 5 from sklearn.model selection, import test, train, test, and split. Calculation of length of test and train splits provide the precision that how huge the dataset has divided the precision models into train and test categories. Comparing the classification score of different algorithms used by bar graph are decision tree, logistic regression, random forest, and SVM. Whereas we see that random forest and decision tree have the same accuracy, whereas the logistic regression and SVM show similar accuracy. Individual prediction and depiction of models. Decision tree, the percentage of correct prediction is 94.7%, and for the wrong prediction, it is 5.3%. Now, the dataset from the X test dataset, I have used 5% of X test and score into X test, that is the background of how this pie chart has been displayed, was used in order to depict this representation. This is for decision tree predictions. Next is logistic regression. Similarly, I have used 10% of X test and score into X test concept, wherein the percentage of correct prediction is 88.9%, and for wrong prediction it is 11.1%. For random forest, the percentage of correct prediction is 92.8%, and for wrong prediction it is 7.2%. Here I have used only 7% of X test, X, X, X test dataset. The support vector machine, or so-called SVM, the percentage of correct prediction is 86.0%, and for wrong prediction it is 14.0%. The percentage that I have taken from X test is 13%. The conclusion that we derive after the predictions and the model has done its work is, based on precision prediction pie chart accuracy score, we can say that random forest classification and decision forest classification, as shown before equally, are the best suited for this problem statement, where we are predicting whether the text given by various customers to various hotels through various sources are deceptive or truthful. The references are from Kaggle, where the data set is taken, Geeks for Geeks, where the information that was needed has been taken, and Sahel, from where I used the site that I used for downloading the data set. Thank you.